if there's anybody new who wasn't here in the previous session, I'm Val Smith. We got Dave Kerb over here. Colin Ames. And just because I'm stubborn, I'm going to try the demo again because there's no reason it should have failed. And, you know, in the break, it worked twice in a row. And there we go, it worked. Woo! No. All right, so now we're going to talk a little bit, you know, sort of similar concepts, but we're going to move into the web arena. So this is sort of the workflow of the web phishing stuff that we've been working on is, you know, direct your target to your website somehow, whether you send them an email and convince them to go, or some URL redirect thing, or whatever. Then enumerate your target using some web interface. Now, Egypt just rocked it earlier, and then we're going to totally integrate with what he's doing. But we're going to give you some sort of like manual, hands-on kind of ways if you want to build your own tools, or at least understand the underlying technology of how this stuff works a little bit. Next thing we want to do is social engineer our target into believing that everything's cool. You know, nothing bad happened to me, it's all normal. And then we want to be able to execute code on the target in some way, whether it's with social engineering by getting them to run applet or some code like we showed with the PDF, or an exploit or whatever, handle all the incoming shells from the targets, and then automate our post-exploitation activities. We want to do all this using something reliable, not MPAC or Tornado or any of those. So these are sort of the components. I built a real quick and dirty client-side enumeration web application, basically. And so I'll explain what each of the components are, and then we can throw it away and use what Egypt's doing because it's better. So basically some OS detection, IP detection, stuff like that, decloaking. And then we're going to move on to signed Java applets, because those actually give you quite a bit of power to do some crazy things. And then some obfuscation. All right, so the general sort of framework concept here, we built a bunch of functions, mostly PHP stuff, which PHP sucks. And this could be done many different ways, better ways, but this is what we've got. And if you're out there and you're trying to learn how to do this or understand sort of what real attackers are doing, this will give you a good idea with some, like, at least clean code that's easy to read. So we've got all these different functions. And the first function is to generate a HTTP header, you know, build up our web page to do whatever it is that we want. And then we've got something we call a bounce URL, meaning like if they don't have even JavaScript turned on, we just bounce them off to something we don't care about, because they're not going to be probably a target we want to go after if they have all their stuff turned off. So one of the things that at least we care about is to verify that our target is in scope. A lot of times we put this attack on an actual client's web server, like we'll break into their web server, put all our code on their web page. So we want to make sure we're not hitting random people on the internet that are just browsing to our customer, because that would be bad. We only want to get the customer's IP range. And some of the ways we enumerate that we talked about earlier with proxy logs and things like this. So we actually have some code here that basically checks the incoming target IP using environment variables and decides, is this in the range of the scope that we want to target, or is this somebody else? If it's somebody else, bounce them out, send them off to some innocuous web page, don't hack them. So then the next thing, there's like a theme throughout all this that involves fish, in case you haven't noticed already. Then we want to verify that they've got Java installed. There's a lot of ways to do this, but we've got some simple JavaScript. We've already verified that they got JavaScript running, so we know that at least we can do this. Next thing we do is verify that they've got Java running. If they don't, we bounce them out. Then we want to detect what operating system they're running. So most of the stuff Egypt talked about is like way more awesome than this. This is just simple user agent string matching. The nice thing though is in corporate environments, we rarely see just regular corporate users spoofing their user agent. Sometimes you'll see their proxy doing it, but for the most part, this is almost always real. And if it's not, they're going to be doing other weird stuff, so we probably don't want to target them. They'll be a more hard target for us. So next thing, we want to get some info about at least what browser they're using. Mostly for our logs or whatever types of stuff we want to do. So I've got a whole function here for like detecting different browser types using user agent strings. And then occasionally, like if you want to do some sort of like behind the NAT proxy or firewall automated attacks, or just enumerate the target's internal network, there's some tools for doing this. I have some decloaking JavaScript here that will attempt to get the target's internal IP if they're behind a NAT and provide it to you. There's a variety of ways to do it. I'm not going to read all the code. You can go and check it out later, but it's basically all there. And if that doesn't work or isn't sufficient, you can do this using a Java applet. It's a little bit more powerful. There's a website out there, reglos.de, which has a cool applet that somebody may have decompiled at some point and read how it works and modified a little bit. Not me, though. So you can use a Java applet to do the same sort of thing. And if you're really interested in decloaking, HD's got a website out there, decloak.net, where he does like iTunes stuff, Word documents, like every possible ability to decloak an internal IP address on a victim that you can imagine. He's got it out there on his site. So I recommend checking that out. So then for our purposes, we want to log all this information so that we can keep track of what each of the targets is. So we just have a simple logger function that grabs things like the OS, the browser type, any other information we can get, their internal IP, whether or not they're in scope, so we can keep track of what happened to put into our report or whatever. This is sort of an example page. Normally you wouldn't display this to the user, but it sort of shows all that information I just talked about there and a string that keeps track of the date timestamp. So next is a social engineering aspect. Okay, so you can enumerate the browser. We're not going to focus on deploying exploits because Autopwn pretty much has that tied up. We're going to discuss the social engineering aspect of this and distributing Java applets to get our interpreter running on the target. So the idea here is the client hits a web page, Java applet pops up, they get a little message that tells them, some information about it, they click run, and the applet in the background downloads an interpreter, executes it, gives us a shell or whatever we want back. So I've got an example of a really simple Java applet. Basically goes out to a website, downloads an interpreter, and then executes it. So that's cool, but how do you make it like a little more deadly so that the user's more likely to click on this and enhance the social engineering aspect of it? Well, you can cryptographically sign Java applets. And so why not sign it as your target? If your target's companya.com, sign the Java applet as company A. So when they get the little window that pops up and says, hey, this Java applet wants to run something, they can say, oh, look, it's signed by my company. I better trust it. So most users will probably fall for this. At least in my experience, they do. You're probably going to want to change up the file names of the Java applets in the code to reflect the target's infrastructure. So like when the applet comes up and gives them its file name, it looks relevant or like something they expect. If they're using WordPress, make sure it looks like it's part of WordPress or whatever. So right here I sort of have step-by-step commands for how to cryptographically sign a Java applet as whoever you want. Now that doesn't mean that the certificate is valid. That's why they get the pop-up in the first place. But 99% of the users out there are going to have no idea what's going on. So first thing you do is you take this code up here. You can modify it if you want or make it better. I'm not a Java programmer, so it's probably pretty crappy. Compile the applet, generate a class file, build a key store, and set the passwords to whatever your target organization's name is. Sign it and create a secured jar, generate a certificate, import it, and then off you go. So once you go through all these commands, you're going to end up with a collection of files that you need to carry out this attack, including the class file and the jar and all of this. And then you're going to want to build a web page to distribute the applet. So I've included some really simple example code for handing off the applet. You might want to put this like in an iframe with your target's actual website as the real frame so that it looks normal. So this is a screenshot of what it sort of looks like to the victim. They're going to get a little security pop-up. Now, I sign this as MetaPhish. Typically, you'd sign it as Cisco or Microsoft or whoever you're attacking, and put something that makes sense as the publisher. And if most users, if they see something in the name that belongs to their company, they're not even going to question it. They're just going to click run. So when we do this, let's say we've hacked some company's web server. We've put all of our client-side enumeration stuff on there. We put our malicious Java applet and signed it cryptographically. We want to be able to handle like however many incoming shells that we have. And we need to be able to automate a bunch of stuff, because we're not going to be able to sit there and every time a user clicks on their own web page and sends us a shell, okay, let's go dump the passwords, let's add a user, let's do all this post-exploitation stuff. So we want to use a script. This is really why we've decided to build all this on top of Metasploit, because it provides Meterpreter and Meterpreter scripts to do all this stuff for you. That way, you don't have to spend huge amounts of labor. One thing to note is trying to understand what ports are allowed egress from your target so that your Meterpreter shell talks out over those ports and doesn't get blocked, because it sucks when your Meterpreter gets blocked. Okay, so this is just, this is pretty simple, but if you aren't familiar, this is how you create a standalone Meterpreter so that you don't have to deploy it as an exploit. We typically use the reverse connection because we assume there's a firewall in place, set up our IP, and we got the command line there for you if you want to follow along later. And then the next thing we want to do is run the Metasploit console and set up all our parameters to match the standalone Meterpreter we made here, including the port that it's going to talk to and the IP address and all that. And then pick whatever payload we want to use and give it the script that we want to auto-run to gather any post-exploitation commands and all that kind of stuff. So, the idea here is, okay, well, deploy the Meterpreter to your target using whatever means, whether you embed it inside a PDF like Colin showed earlier, you put it on a malicious website with a Java applet like I'm talking about, or you use some exploit to do it, or email it directly. Then, you want to wait for the stager coming back like we showed in the previous demo, and success. So a little bit of note in case you're not familiar with the way these Meterpreter scripts work. They'll scrape a bunch of information on the target, like passwords and network settings and all of this stuff, and they'll throw it in like whatever home directory Metasploit's being run out of, logs, scraper, and each compromised target will generate its own directory that's like IP address, data, timestamp, and that way you can go and keep track of all the people that you've compromised and keep all their information organized. For this particular script, you'll get a list of stuff like environment variables, what group memberships there are locally in domain, hashes that are dumped, network neighborhood information. So like you're enumerating their internal network without really doing much. Services that are running in case there's like antivirus, so you need to stop that. What users are in the system, all those basic stuff. There's a guy out there called Dark Operator who's got a ton of Meterpreter scripts that are useful to at least get started with, look at. Okay, so I'm going to talk a little bit about obfuscation. I mentioned earlier that you might want to throw like your Java applet stuff into an iframe. Well, the problem with iframes is that a lot of people are looking for these as a vector for getting exploited, like whether it's host intrusion detection systems or antivirus. So what bad guys are doing, what real attackers are doing, is they're obfuscating up their iframes in a whole variety of ways. Egypt talked about some Ajax stuff to like stage each piece of your web application, which is pretty cool. In this case, I'm going to talk about using JavaScript to break up the iframe. I've actually seen like Chinese malware sites do this, where they'll take the word iframe and break it into little chunks and reassemble it in JavaScript. And like your frame border and your margin width and all that, it's literally all broken up. So if you've got a host-based IDS or antivirus or whatever that's parsing incoming HTTP stuff, looking for strings that match iframe or whatever, they're never going to see this. Now, an analyst or a person will look at that and go, oh yeah, this is, I know what's going on here. But at that point, they're already owned, so it doesn't matter. Other types of obfuscation to get around those types of things are character encoding, basically convert their URLs or their commands or whatever to characters that are going to get decoded by the browser so that they can get executed. Any automated tools that parse from malicious strings are going to get killed by this. And it doesn't have to be very complex. It can be almost any kind of encoding will bypass most tools out there. So basically, the attacker writes a small function that converts all these values back to the actual string. Almost like a packer, but less intense. You do things like basically hex encode your strings, your iframes, and escape them, %, escape them. Once, this is a big blog of crap. I don't think I've actually seen an antivirus or a host-based intrusion that will fire off on this, I'm sure they exist out there, but I haven't run across it yet. Once you decode this, or your browser decodes this, it's basically just a simple iframe. So a similar technique to this one is to use, you can use a whole bunch of different customized encoding routines, like you can unicode it up or anything you can imagine. There's a whole bunch of examples on Script Asylum that are useful to at least get you started on how to do this kind of thing. And I already mentioned Egypt's talk about 10 times. All right, so we're going to do a demo of some of this stuff, hopefully. Hopefully we don't have to resort to the movie. So bear with me while I get stuff set up here.
So he showed you all this code for doing all this and putting up your own web server and so forth, but this is about Metasploit. We have a module to do it for you. How about that?
Yeah, I forgot to mention that part.
Sadly, it does actually make all the calls to Java and does use the Java compiler and all that. You need the Java development kit installed to do this, but it's a good step forward in sort of trying different things out. HD was talking that, oh, well, we'll just throw Java bytecode and generate that on the fly and throw that in. So maybe HD will come up with something that'll do it for us without a Java compiler. If that's the case, that would be impressive. So we'll see. Stay tuned.
I'm old, so I have to have like notes to remember all my commands and stuff. All right, so basically what I'm doing is I'm telling it what IP address to talk back to, what port to listen on, what post-exploitation script to run. And now I'm going to go set up the MetaPhish module. Colin did a lot of work on this. It's really awesome. So far, so good. The right way to do this is with a resource file.
But he loves the pressure of typing under, the watchful eyes of many people.
So these two things kind of have to match up for it all to work right. So in keeping with the picking on China theme, we've actually used China as our URL to go after, the Chinese government site we talked about earlier. Hopefully they don't come after us. This is a little crappy with this terrible resolution.
At least I didn't need notes. Gosh.
Well, yeah, you're young. You don't have Alzheimer's yet. Although your demo did fail.
It did. And then it succeeded.
Mine's going to explode, you watch. The karma is going to get me.
But it's my module.
Oh, yeah. Do you want to type all this stuff?
No.
Yeah, I could do that, but... All right, so a lot of crap. Everything's set up good, I think. So we're going to exploit this. Hopefully. So you want to explain what's going on here?
So you can see, so it actually randomizes up, in this case, it randomizes up the name of the class and everything, generates a Java file, compiles the Java file, signs it, signs it with the name you provided. I think the name we have in there is MetaPhish LLC, and then hosts it up using Metasploit's HTTP server.
All right, so we need to set up also a multi-handler to catch any shells that come in from this. So over here on the target, once it lets me log in. This poor box has been exploited so many times. So all of that random PHP and JavaScript and whatnot code that I showed you earlier, so what we're going to do is we're going to hit that page, it's going to enumerate the browser, figure out the OS and all that crap, and it's going to hand it off to something that's going to launch, it's going to hand it off to his module, which is going to launch the Java applet. In the future, we're going to put all this in a module, but this is what we got so far. So if all goes well, it's just slow because it's a VM. So you can see the target sieve that we call it basically enumerated the client and shipped it off to this other site, which is a cn.gov site, which
you don't have hosted, so it doesn't work.
I do have hosted.
The applet is running though, just fine. Leave the applet alone.
Give me 1 second. Well, it seems to be running.
Video time.
All right, so relying on the video. So we'll show you what it looks like on the target. The target basically goes up to the sieve that we built. That's going to hand it off to this other site, which is going to iframe in a site that looks legitimate, typically from the target that you want to go after. And then you can use all those obfuscation techniques to make sure that that iframe doesn't get caught. So what the user is going to see is essentially this website. It's going to get a, whoa, that went by really fast.
Yeah, you're very fast to trust. You click quick.
Like most users, I clicked it instantaneously. So you can see, we randomized that name, but you can set that to, target LLC or whatever instead of this, so that it looks normal to the target. So they click yes, trust. So we're combining web with cryptographically signed Java applet, with social engineering, with PDFs, with combining all this crazy stuff together. And then over on the attacker side, we'll move to the money shot here. What's essentially going to happen is you're going to get a interpreter session because it gets launched by that Java applet, and it's going to go through and start scraping all the information from the target. You can connect to this session, get a shell, or typical interpreter type stuff. I'll skip by this. Wait, I got to show shell. Yay. All right, and then it goes and grabs all the information about the target host, like hashes and everything else. I'm glad we kept in the theme of demos failing like most of the demos today did, so that's pretty good. All right. You guys got anything else you want to say about that part?
No.
All right, Dave, you're up.
So a little while back, I just kind of got interested in Tor, not just for browsing, but as using as a tool for both pen testers or whatever evil you really want to go for. So what I want to go over today is kind of some other alternative uses for Tor. Not only can Tor be just a way to anonymize, but it can actually make you be whoever you want. So one of the things that you can do in Tor is you can go ahead and set up your exit node so it's not random anymore. Now this is bad for anonymity as if you do it for the long run, but it's really good for a pen tester. So instead of having to, have you ever noticed how some websites, they're trying not only set up different languages for what region you're in, but they try and be smart about where you're coming from. So they go and buy a subscription to GeoIP, and then they try and send you to the right server, depending on where you are. Google's notorious for this. Anybody who's used Tor and just comes out random exit nodes is very familiar with this. But it got me to thinking, well, sometimes these sites aren't exactly the same everywhere. And sometimes they trust different people depending on where you're coming out of. So on some of the sites, well, we're going to pick on China again. So some of the sites that we've worked on for...
They pick on us.
Yeah. Some of the sites we've worked with that have gotten hacked, a lot of times it ends up being China, and their immediate response is they go and block the entire IP range of China. So this is effective immediately, not always everywhere though. So the idea is now we can pop out right in China if we wanted, or in the US if they were coming after us, and that way the country blocks no longer work. This also works for sometimes, well, maybe somebody will have a little bit more access to the city they're in. So there aren't Tor nodes in every city, but it's a way for you to go ahead and try and look without having to travel everywhere. Now maybe you want to travel to China and just ignore the rest of this talk completely, but it's an idea. So there are a lot of ways to do this. If you go and read the documentation, Tor claims that you can just go ahead and put a country code in and it'll work. In general, it doesn't. The beta will work a little bit with it. But also, one of the things that I found is I don't particularly want to tip that I'm coming from the Tor network. So if I have a scan running and every 10 minutes it's switching IP addresses, that's a pretty bad sign from somebody who's looking at it from from a forensics point of view, that they're going to say, okay, something weird's going on here. So I really do want to pop out a 1 for an entire scan. Maybe pop out somewhere else for the next scan and then randomize it. But for one scan, I just want to pop out a 1. Let me see. I kind of, for the people who aren't familiar with Tor, I decided I'd just go ahead and give a little bit of background on how to actually choose your nodes. So Vidalia, of course, being one of the major ways to start and stop Tor is an easy way to go through if you're in a hurry, and you can go down the list and there's little flags indicating the country of origin, so you can choose your exit node. I circled 2 here that are the Chinese flags that I don't think you can see, but I went ahead and highlighted one of the ones in particular, the Psi Online. So in your RC file, you go ahead and you can put in this name, so the Psi Online from the previous demo, and say that I want to strictly use the exit nodes that I defined. Then you'll pop out there. Now you have to be careful though. If there's duplicate names inside of that list from Vidalia, won't work so well, especially things like unnamed, which are a lot of the Chinese nodes for some reason. But all of a sudden you could come out of any unnamed node. So there's another way though. There are lots of websites that will track the status of Tor. So this is one, and this will give you a unique key. So you can go through, find the place you want to pop out of, the information, maybe choose the exact city that you want to go to, if there's a node available there, or somebody who has high bandwidth. And then you can go ahead and take this unnamed node, do a little bit of a conversion, and then you'll be able to pop right out. So here's the actual example of the unnamed node. So again, popping straight out of China. As a side note, this is actually an interesting thing that at least I found funny, that it tells you a lot about that exit node, that if you wanted to attack the exit node, you really wouldn't want to give away. I mean, do I really want people knowing that I'm running Windows 2003 Service Pack 2 with single user and terminal services? I just found that a little interesting. Don't know why they decided to give it away. So this one's mainly in here just if you want to go do it. Just telling you where to go, how to get to the RC file. Now, one of the things when I've talked with people in the past about Tor is they get really confused about what you actually have, and they end up doing things that will make if they're scanning over Tor, if they're doing something a little strange over Tor, will make it a lot worse. So Proxy is your normal HTTP proxy. Now this is on port 8118. Now the thing about this to remember is it's trying to clean everything for you. It's trying to get rid of JavaScripts that are dangerous, trying to get rid of anything that might leak your IP. But if you're trying to do something like an Nmap, you really don't want it to do that. So this is a bad choice. Well, Nmap's a bad choice, but NIC2 is a good example. You don't want to use the Proxy port for NIC2 because it will end up changing what the results are and giving you weird answers. So on the 9050 port, that's your full SOCKS 5, and of course Vidalia is just the user interface. So anything TCP you can end up doing over Tor with some success. It's just a matter of figuring out what tools to run, how to run them, and all this stuff is publicly available. I'm not really giving anything new until the tool a little bit later, but it took a long time figuring out the little quirks and what's going wrong and what to expect. So that's what I'm really trying to give you today. So there's three major proxy programs that you can get: Proxy Chains, TSOCKS, and TorSOCKS. So what these do is they go ahead and they grab the socket call, and so anytime your program makes a socket call, instead of doing a normal socket, it sends it over the Tor network, or any proxy network in the case of Proxy Chains and TSOCKS. Another useful little tool, side note, so Proxy Chains is very useful if you're in a network that blocks outbound ports but has an outbound SOCKS proxy. Works beautiful. You can do SSH over that proxy, you can do almost anything. So nice way to get out of a network if you end up doing a pen test and you're stuck a little bit. So back on topic a little bit. Little things to keep in mind. Try and use IP addresses when possible. You really don't want to do anything with a NS lookup in it. TorSOCKS is pretty good about trying to catch those and warn you that you're trying to do a direct NS lookup. Since NS lookup is UDP, it'll try and go without going over the Tor network. So this could actually give a little hint to you who you really are when you go after your target. So also try not to run as root. As we all knew, root has higher privileges, but like Nmap, for example, it'll go ahead and open up a raw socket for speed. So it will bypass all this proxy chains and TSOCKS and TorSOCKS and just go straight out to your IP for you. Not so good. Another thing that I've done, just to save your own butt, if you're really trying not to tip off the people you're scanning, is set up a firewall with an outbound firewall that blocks your target. It's just good practice. There's been more than once that I've accidentally, they get to claim a win because they saw me, and it was just completely inadvertent, I forgot to put TSOCKS in front of my command. So, a little bit about setting up the proxy chains. I personally, all of these have good and bad points, so I'm going to go over the setup of all of them. I don't recommend one tool exclusively, but the proxy chains, this is actually fairly straightforward. You end up creating a dynamic chain that uses SOCKS 5 to your local host on 9050. So what that's saying is all SOCKS traffic that you use proxy chains for will go over the local host to that port, which is your Tor port. Now, if you want to use it for an outbound SOCKS proxy, just change that to your outbound SOCKS proxy. The important part here, for if you're going to be doing scans or anything, is you're going to want to play with the TCP read timeout and the connect timeout. So because you're going over Tor all of a sudden, you're going to have things that, especially if you're going to far off destinations or you end up going through a lot of hops that happen to be overseas on the Tor network, those timeouts need to be fairly long. The bigger they are, the more likely you are to get better scans. But if you make them too big, you'll end up with really slow scans and some weird false positives sometimes. So it's just something you have to play with. The TSOCKS, basics, same setup. You don't have the option of the timeouts in TSOCKS. TorSOCKS, if you're using it for Tor, basically set up out of the box for you. You can play with it some. Not going to go into that a lot. So now we're actually getting into some of the stuff that's a little bit more fun. So you can Nmap over Tor, something that a lot of people don't think about. The timeouts become problematic. You have to watch out for your exit nodes because some of them have policies that block all 135 traffic out. So sometimes you'll get false negatives or false positives depending on which exit nodes. It's a nice place to start though, especially if you use the -A option in Nmap, because it'll end up telling you, if you're getting a response back for the port, it's very likely that that port is really there and something, at least it exists. And never UDP. Try to say no ping, no name lookup. So we did an example. We went ahead and I Nmapped the blog for attack research, and just to see what we could have. Now, the very first thing is I'm using proxy chains here. And the reason I'm using Proxy Chains is because it gives you some feedback, which can make your scans faster. You can see here on this very first one where the dynamic chain has an access denied. The problem with almost all these tools is they'll go ahead and give the socket command that it was a success back. So all your scans will say everything was open. So you want to sit there and tweak it, and the Proxy Chains will allow you to do that. Anytime you see an access denied, means that the access node or the exit node actually couldn't reach 443 on, in this case, actually that's not blog. I don't know who I scanned. Whoever I scanned, it couldn't reach the 443 on that. So I went ahead and I took that out of my list and did 80 and 22, and it gave me a whole bunch about, okay, I know that they're running Apache, I know that they're running SSH, and I know that they're on a Linux system. Now, because of the SSH, it gave me that they're running Ubuntu as well. So found out a lot about them. They don't know that this was coming out of some random node in China. So they have no clue. In fact, here it is, the actual scan. So I have my entry node, which was in Germany. Germany was my middle node too, and then I exited out of China going to wherever my attack was. And you can see where the SSH was open, and that was the actual scan. So all over Tor, no hints, makes it a little bit hard on the defense, but that's kind of what we're here for. But you can do a lot more. So I kind of hinted at it before. You can do NIC2 over Tor. Now, for people, NIC2 gets a bad rep because it gives a lot of weird data. But for anybody who hasn't used it a lot, I definitely recommend it. It's a lot of fun. I have rooted at least 3 or 4 different sites with that because it finds usernames, passwords. One time, somebody put in a web directory that had a weird name, but NIC2 happened to look through it. So Dirgrinder is another one that will do this, but NIC2 looked for this directory, and I forget what the directory name was, but the important part was there was a document in there, and it was the build document for their site, including all the usernames and passwords for administrator, and where their SQL database was hosted, and everything else. Another one, NIC2 was able to actually give me the username and password to the home directory server for a major institution. So that was kind of fun too, because it was just a matter of sitting there and, oh, I can log in and do anything I want as anybody I want. Well, that makes work easy. So, but the nice thing is, as I was mentioning, you can do this all over Tor. So you can use it, this is, for a long time I made this mistake, don't use the built-in proxy option with Tor over Privoxy because you get really weird results and a lot of false positives and false negatives as Privoxy is messing with the data. NIC2 is not actually running any Java, it's just grabbing and looking for things. So it's fairly safe to run it just straight over the Tor network using tsocks, or Tor socks actually. So here's an example of this one actually is against blog. So the host is, the host name here isn't actually doing a resolve on the host, it's filling in the target host name so that you go to the right virtual server on the HTTP when you go. So that's not actually a leak there. And then on the very end, we have the IP address that it's going to. So this is a way you can go through. It took about 20 minutes, I think, for this scan. It wasn't terrible. It's not fast. You're never going to get a fast one over Tor. Never going to get anything fast over Tor. But it's just a way to go ahead and do something, you know, while you're off doing something else, you can have a VM running your Tor and just kind of going in the background, doing your various scans. So I had a little bit of fun one day. I decided to VPN over Tor. You can do it. It works. It's painful and drops a lot, but it does work. So it only works with TCP-based VPNs. So PPTP is one. There's a couple of others out there. Anything that uses UDP won't work over Tor. But, and it requires 2 machines. It's a little complicated to set up, but it's just another way to think about how to attack a box. So what you end up doing here is tsocks, TorSock, all the proxy chains, they hook all the outgoing connections, but not the incoming connections. So you can use a port redirector like I use TCP-XD, which will go ahead and take the incoming port 1723 in this case and send it right back out over Tor to whatever 1723, wherever I tell it to go, whatever the IP address is. So what's nice about this is now you can run really odd applications that are a little harder to hook. So like PPTP. So we were able to VPN in with a Windows box and just have it connect up to the VPN on the other side. Yeah. So had to tie it into Metasploit a little bit. I can't take a lot of credit on this one. I just read it from a post. But for a while before I read this post, I used to use Tor socks with Metasploit, and it was a little bit painful and things would act weird. Turns out there's just a global proxy setting that you can set right to your Tor port, and it'll go right through. Again, you have to be careful. You cannot use reverse shells. That would be a very bad idea. Kind of gets rid of all the anonymity part. But it is a way for you to get in with a TCP Connect shell. And again, you always use the IP so you kind of avoid leakage. So, yeah.
This one we're not going to do live for
Yeah.
obvious reasons.
Doing Tor live here at the Black Hat Network is going to be very problematic.
Especially because we're going to end up attacking somebody over Tor.
Do you want Metasploit over Tor or Tor backdoor?
Okay, I'm going to have to pause this one a lot because I told VMware to drop all the non-interactive frames when I was doing this movie, and it made things go very, very quick. So we'll go ahead and start up the Metasploit console. Let's see. So all I'm ending up doing here is I'm just going to go ahead and take the newest 08067 vulnerability. We're going to go ahead and run that over Tor. And so we're going to go ahead and set that up. The big thing to keep in mind here, let me get just a couple of frames more. So I'm setting up my R host. For those who are wondering, I'm not dumb enough to put a vulnerable box that's Windows on the network for any amount of time because it'll get pwned before I get to do the demo. So that's why for the weird R port, I had my firewall redirecting, so at least I had a little bit of time. Again, we want to go ahead and use a bind shell. We don't want to use any of the reverse shells. And for those who are curious, you can do, let me pause. You can do VNC over Tor. It works, it's slow, it's painful. You don't want to use the VNC inject from Metasploit as is, because the problem with it is it tries to connect in 32-bit color, which is not going to happen over Tor. But you can do it in 8-bit color. So if you install your own VNC, it will work over Tor. I've already P'd over Tor. It's not comfortable, but it's nice if you need to go there and you need an interactive shell in order to do something like download a payload that you just can't seem to get any other way, or if you need to execute something that you just can't quite get to over the command line very easily. So let's see. We went ahead, we set up our backdoor here. We have the remote host set up. So here's where we go ahead and we set that global proxy so that we can say, okay, now send all of our traffic over Tor. We'll go ahead and exploit. Now in reality, this took a couple of minutes, not just a couple of seconds, but we were able to get a shell. So it is a full working shell through Metasploit over Tor. And this can pop out anywhere in the world you want it to. Just define your exit node. So let's see. What button do I hit? Oh. I am not the PowerPoint ninja. Okay, so first question, of course, I had is I want it to call me back, but how do I do that anonymously? So Tor does have the idea of hidden services. So the very first thing that you can do is you can set up a hidden service. The only problem is with these .onion domains, you have to have Tor on the on the other end. That's problematic. You can install it if you want. I mean, Tor's not huge, not very hard to install, especially on Linux boxes. So you can install it and then go ahead and start it, and then you can get to these .onions. And those .onions we can get to through Proxy or through any of the TSOC stuff. Currently, you can't tell where a .onion's coming from. There have been exploits in Tor, they pop up here and there. There's some theoretical timing attacks. So that's not, they might be able to tell where you're coming from as far as a country, but right now, at least, it's a fairly safe thing if they don't really know where you are. So you can go ahead and get a bash shell over Tor. It's actually not too hard. It's using the same idea that we've done before. We set up the hidden service in our Tor RC, just tell it where this where the hidden service directory is. So that's where it's going to keep your host name, because your host name looks like it's a cryptographic name, .onion, and a little bit of information. And then you tell it what ports. So what port on Tor is going to go ahead and forward to what localhost port. So that's how you set up your services and get everything going the way you want. And then you can go ahead and just start netcat on that local port. You don't have to do anything on the server real special. Just set up the Tor.rc file and restart Tor. On the attacker side, or client side, I guess, the person you're trying to shell, you can go ahead and just run Tor socks with a netcat or with a bash. You can do it with either one of these. But that works, but that's a lot of work. You don't really want to put Tor on the end. So what we did is we went ahead and wrote a backdoor. Now this backdoor is a little bit interesting. So what I ended up doing is I bounced everything through this website called torproxy.net. Now, the reason that I did this is a couple. Now, there are lots of IDSs out there that will detect Tor for you, but this is just HTTPS. As far as the client knows, they're going out to an HTTPS site. They can't actually read the data that's going across because it's all encrypted with SSL. I'm sure after this talk, a whole bunch of sites are going to end up blocking torproxy.net. There are at least, I don't know, I think I found at least 5 more that are like this. I picked on torproxy.net because it's the biggest and the fastest, which makes my shell a lot nicer to use, a lot more comfortable. So this isn't a real featureful shell. It works. It proves the concept. But you have to recompile it to get some of the .onion stuff there. I'm working on getting that better, but I didn't have enough time ahead of time. So some of the benefits, of course, you don't need to install Tor on the client, which is really nice. Don't know who the server belongs to, so all that's going off into the ether is all that really this place that has this backdoor installed can tell. And it's doing HTTPS. In fact, the one that I'm releasing here is doing HTTPS. Of course, the downfall, torproxy.net can read all your traffic. So if you don't, there's someplace in Germany, the guy promises that he's nice and won't read anything, but that's a promise. Don't exactly trust that. But, you know, from my point of view, I don't really care. So some guy in Germany can see the commands going across the wire. He still doesn't know who the server is, and he knows who the client is, but all he really knows is that the client got hacked, and these are the commands going across the wire. Now, I could SSL those commands or do something really nasty there, but I haven't yet. So it's an asynchronous process. It's not, you have to wait a while. It's the backdoor just basically probes for any new commands that are coming through, and then we'll send the output. So it's not an instantaneous shell. It's not interactive. Everything that we send across is spawned off in its own instance of bash or CMD. So it's not like you're going to be able to run a command. You're not going to be able to CD. It's just going to be off in the ether. But after a couple of people were confused, I went ahead and I decided to draw this diagram at least. Did it right down there a couple of hours ago. Not really how. So what ends up happening is, so here's your victim that has the bad stuff installed. You either got that through Metasploit. You could have gotten it by packing it in with the PDF stuff that we talked about earlier. Who knows? Maybe you just send them a CD and it happened to have the executable on it. So when the traffic leaves their network, all SSL encrypted. They won't be, if they have a full packet capture or anything, they can't read what's going on. All they know is the traffic's going to torproxy.net. At that point, it enters the Tor network over the Tor protocol. So yeah, if they're blocking Tor, their firewall here, doesn't matter. It's all going out HTTPS. And so when it leaves the Tor protocol, right now it's coming in clear text to HTTP to this .onion server, which is my attack server. So this one I have a little bit better demo for. Oh.
So basically what Dave's done is write a second stage backdoor that's SSL encrypted, communicates completely over Tor, so it's totally anonymous, so the victim won't know who the hell hacked them.
Okay, so let's see. The other side note is the client. So I did all of this in C# on mono. And the reason why I did that is a couple folds. Since we're it looks like we have plenty of time. Lesson learned, make sure that you know where you keep your backups. So I was good. This is the second time I wrote this code. First time was in Ruby, and I rebuilt my machine thinking I made my backups. Colin even saw me make my backups. Then when I went looking for him a month ago, right before the talks, I couldn't find him. So I rewrote it. So this time I went ahead and went with C#. What's nice about this is that the same binary can run on Linux and Windows if you have mono installed.
No recompiling needed.
Yeah, no recompiling, no difference. Just drop it where it goes, and there you have a command or a backdoor. So all it requires is .NET 1.1 on Windows, which is fairly common nowadays, unless it's a real fresh install of XP, and mono on Linux, which some people might think is kind of weird, but Ubuntu installs it by default. Debian's adding it to the tree. Fedora's adding it to the tree. So I mean, it's not something that's exactly rare on Linux. So that makes it a little bit nicer when you're actually sending out your payloads, because you don't have to worry about, oh, well, what's my target? Just send it. So first thing I'm going to do is I'm going to start up the Windows server. So this is where I'd enter the commands. Now I'm setting up the Linux client. So this is just me setting everything up, getting everything going. So the important part here is I'm printing out an error message, just telling what the HTTPS request is going to look like. So you can see that it's going to HTTPS, it's torproxy.net, and at the very end, here it is on the Linux side as well, there's this .onion address. So that's where it's actually sending the data. So on the Linux side here, I want to go ahead and run a command. So on the other box, I want it to do an ls-la on /. This is going to take a while, so we'll go on. We'll see, here it is sending the actual data back over the Tor network. So at the bottom here, I have the torproxy.net. It's sending it in 200 character modified base 64 chunks. So it's base 64 encoding, except I changed the / and the, I forget what other characters that were causing problems going over HTTP.
/ and equal.
Yeah. So here it is again on Windows, same thing. Every 200, it's just acking, saying what's happening. So if we go back here over to the Linux side, it's already done. Here's the ls-la on /. So all over Tor, able to get my commands executed. Now, I don't want to try and fool anybody to how slow this is, so we're going to go ahead and run just a uname -a, not anything really fancy, probably 1 or 2 packets back, and here we are waiting for the data. So it's not fast. I'm not claiming it is, but it is a way to keep yourself hidden and a way for them not to know who's coming from where. There's the uname -a. If we go back to Windows, there's the IP config /all that I ran earlier. So there you go, all over Tor. And that's the video just ending. So let's see. So one thing that we were talking about around between a couple of us about a couple months ago was we were talking about, well, it would be really nice if we had a one that went through Gmail, so you didn't have to go to Tor every time, because we don't really think that Google's going to be, cooperating with just a pen test. If every time somebody got hit just by a pen test, they went and gave all their logs and tried to run everything to ground, they'd be really busy. So we wanted to go ahead and use Google, and our thought was dying DNS to actually trigger the Google in order to get a backdoor that way. Well, as it turns out, somebody released this helpful tool that wasn't supposed to be a hacking tool called Tweet My PC. So this is a nice little thing that right now does screenshots, custom commands, all through Twitter and Gmail. So you go and you make a Twitter post saying, I want a screenshot of this PC. A couple minutes later, it pops right back up as a Twitter pic with a screenshot. So this is another way that you can go about trying to hide without having to go through Tor necessarily. Now, if you're worried about it, you can still go through Tor. That's the beauty. You go through Tor to get to Twitter and to Google, create anonymous accounts, still can hide that way. So it's just another way to look at it. It was fully proxy aware. So I'm giving them credit on that one. That was a nice little backdoor, even if they didn't mean it to be. As a side note, if you ever decide to use this for administration, which it's supposed to be used for, make sure you lock your account, because a whole bunch of people got hacked this way.
Yeah, you can actually like search for everybody that has TwitMyPC installed on Twitter and see screenshots of their desktops. And if you can hack their Twitter account, then you can control their machines just by doing Twitter posts.
Or if they left it as a public account, just go ahead and tweet them, and there you go.
All right, so some of the to-do stuff that we need to do from now on. We want to make a Metasploit module that automatically generates all the client enumeration stuff. Thankfully, Egypt's basically already done that, so we can cross that off our list. We want to integrate more of this stuff with Colin's PDF infector module and do some more creative post-exploitation scripts. I think we're pretty much, there's a lot of people out there who are working on phishing frameworks. Egypt's doing some stuff, Dean DeBeer's doing some stuff, we're doing stuff. So I think we're all just going to get together and put all of these different tools and build one big monolithic tool to handle all this. And we want to integrate more with Dave's Tor tool. So basically what you've seen is we're releasing a Metasploit module that infects PDFs, like existing PDFs of your target. We're releasing a Metasploit module that does cryptographically signed Java applets that deploy Meterpreter or whatever you want. A set of scripts to help you do client-side enumeration if you're interested in doing that, and a second stage backdoor that you can install using all this stuff that communicates totally over Tor and communicates HTTPS and is cross-platform Windows and Linux. So that's all the tools we're releasing today in this talk. Okay, so a couple other things that you should consider checking out. Obviously, browser autopwn, Egypt's talk. Efrain Torres is going to give a talk, I think, at DEF CON on more Metasploit web type stuff. Dean DeBeer has this awesome tool called, how do you pronounce it? Asagi. And here, why don't you...
So we were talking about, a phishing framework, a front end that gives you all the information that, sort of impact style, generation of, graphs and everything, and our friend already did it for us. Isn't that nice of him? So this is just sort of a screenshot of the login page. It gives you statistics of current pen tests that are going on, that sort of thing. Success rates, pretty graphs, statistics.
It's not publicly released yet, right?
It is not released yet. It should be soon, hopefully. And here's some more statistics on, actually clickers. So an important thing when pen testing with phishing is you want all this information later. It's like, well, who clicked when, how? Was it some guy on his iPhone, or was it some person, at the actual corporate office that clicked it? These are useful things and good for reporting. And so Dean has done a great job at harvesting all the information and generating out in large reports. A lot of Assegai works with Meterpreter or with Metasploit under the framework. So this is just a front end, a GUI front end to it, which is sadly written in PHP Egypt. Okay. But it basically just calls off Metasploit commands to set up all of your exploits. So if you have a file format specifically, so with our PDF, that'll be integrated into it, where you will pull in PDFs that you want to infect, and it'll go off and infect them, and then host them up in such a fashion with, I believe he's using MD5 checksums and so forth, so you can identify who you sent it to and who clicked what. And so you can uniquely identify who actually was infected at what time and with what methodology. And it has built-in templating for, to reuse over and over again when you're doing phishings. And this shows some of it where you can actually generate emails, like a new update to this, that sort of thing. Should be more details on this later.
Yeah, Dean made a blog post on carnalownage.attackresearch.com where he explains a little bit more in depth what this is. Is that it?
Yep.
Okay, so we're gonna put all these tools, videos, and slides up on attackresearch.com. We're gonna hand all the code off to HD so that he can rewrite it correctly, and if he so chooses, put it into Metasploit. And we just want to thank all the people who have helped us, tested, or been involved in some way, and thank all you guys for coming and listening to us talk. So if there's any questions, we'll start taking those, but thank you.